As you and I continue to have a fun time together in reviewing how the network operates with layer 3 routing and layer 2 forwarding, besides just the layer 2 forwarding based on layer 2 frames, I also wanted to chat about what about the path that we're going to take through a layer 2 network. If we have more than one path at layer 2, only one of those paths is going to be taken. So what I'd love to do in this video and lab with you as a review is take a look at determining what is the current layer 2 path that's being used, and can we manipulate spanning tree to tweak it? And those are the questions we're going to answer in this video. So let's imagine that you and I have been called into an organization and they've got this topology. Now there's a lot of stuff going on, but they have a specific question for us about this part of the network and specifically about layer 2. And the question they have is, what is the path that Bob is taking when he sends a packet? So here's Bob's computer. He's going up to the internet. As his traffic goes through this layer 2 network, which path is he taking? And we have a couple choices here. Is he using path A, which is from the access layer switch down the trunk to the core switch, or is he using path B, and then from core 2 to core 1 before it gets forwarded out this way? So, just looking at the topology, if these trunks are all the same speed, it would make sense to use path A instead of this path B. Now, the key in a situation like this, from real-world experience, is to break it down into its basic components, which is what we're going to do right now. So part of that is drawing it out on paper or on a computer, on a tablet, so that we're very clear on where the interfaces are and also how they connect to each other. See, the challenge is this, at least for me. When I was getting my first CCIE back in 2001, I started using a technique, and it was called point. So I'd have my topology diagram that I had written out, and when I was working on a device, I would leave the pencil pointed at that device, laying on top of it, or the tip at that device. Now, why does that help? It reminds me, anyway, of what device we're looking at, and also to be clear that we're not going to make a mistake. Some troubleshooting labs that I have prepared for you coming up in many videos from now as part of the CCNA. I've got some troubleshooting labs for you. And as part of that, I invited guest speakers from the team to come in and troubleshoot. Some of them were double CCIEs like myself. Other people hadn't touched a Cisco router in a few years. And it was great to get their experiences. But what I noticed is that even the best of us, we make mistakes sometimes if we're just doing it from memory. So the first thing that we would want to do in verifying this little piece of the network is draw out the ports, and to make sure that we're clear on what ports belong to which device and how they're connected. That way, when we're in the interface, we can look at our topology and say, oh, okay, this is the output here. Oh, and then we can confirm. And that's a much better option for quick troubleshooting and verification of networks rather than just thinking, oh, I'll remember what interface that is, and I'll remember the state of that. By making notes along the way, we can save a lot of time. So let's do that here. If we're working with these three devices, we could separately, and I'm encouraging you right now to draw this out along with me. So here we have our access layer switch. We can just write access there. We have C1, I'll put C1 for core 1 and C2 for core 2. Great. And then we have some links. Now these links in red here, they are trunk links configured as layer 2 trunks. So we got a trunk there and a trunk there and a trunk there. In fact, you know what? Let me, because I can do it with this really quickly, let me do those in red because it's easy. Now, if you're on a piece of paper with a pen, it doesn't have to be color coded. I'm just doing that for the benefits of training. So all right, we have these connections, and those trunk interfaces are 0/1 on the access layer switch, 1/0 here on the core, and from core 1 to core 2 on the core side is 1/3. Going over to core 2, it is 2/0. And then from core 2 to the access layer switch is 2/2, and also 0/2 at the access layer switch. Now, I'm going to double check all my work here. I'm going to pause for a moment and make sure that all my connections are correctly labeled, because that's also important too. If we mislabel it here, we might misdiagnose something. So with this drawn out, I'm just going to focus on this as we start taking a look and see where the traffic is being forwarded. How is it flowing at layer 2? And the commands we can use for that, focusing on VLAN 10, would be show spanning tree, and I'll just put the shortcut there for it, for VLAN 10, and press enter. And if we do that on all three switches, it'll show us which ports are forwarding and which ports are blocking, specifically for VLAN 10. So we'll start there. So if you're logged on to the CBT Nuggets website, I'd like you to do two things. One, write out this topology with these three devices, and then secondly, click on the link for the virtual lab, and let's go verify this together. As my lab is loading, I'm going to grab a quick drink and also make sure my documentation is in place, and we'll start in just a moment. So with our topology in mind and our lab open, let's go ahead and start with access switch number 1. We'll do a show spanning tree for VLAN 10 and press enter. And then we can document the state for these interfaces. So they're all forwarding, and the interface gig 0/2 is the root port, meaning facing the root switch. And that's a little bit of a giveaway right there as far as who the root is, because gig 02 is this port. So if this is the root port, meaning pointing to the root switch is core 2, based on the cost here that I see to get to that root. So I'm going to put a little R there, meaning root port. Next to 0/2 and also 0/1 is forwarding. We'll put a little F there for forwarding. And gig 00 here is also associated with VLAN 10. That's an access port, and that's actually where Bob's computer is connected. All right. So we'll issue the same command, show spanning tree for VLAN 10. We'll do that on core 1, and we'll also do it on core 2 to discover the full topology. So over on core 1, we'll issue the same command, show spanning tree for VLAN 10. Press enter. And so on core 1, it indicates that the root port is gig 1/3. That's this bad boy right here. So it's forwarding towards the root. And gig 1/0 is blocking. Oh, bummer. So spanning tree is causing this port to not forward traffic, hence preventing a layer 2 loop. Now in your lab, if we go look at core 2, what we're going to see is that because it is the root, it's the root bridge, all of its ports are going to be forwarding. So let's go ahead and confirm that as well. So we'll go to core 2, we'll do a show spanning tree for VLAN 10, press enter. Sure enough, this bridge is the root, and both of its ports are forwarding as a result. So if we were going to identify the path that Bob's traffic is going to take, Bob's traffic is going to go like this. It's going to go to the access layer switch, down this trunk, then over to core 1 because the next hop router is down off of core 1. So this is not an optimal path. So to change this, what we could do is we could use some spanning tree commands to make core 1 make it the root of VLAN 10. And if we do make it the root, then all of its ports will be forwarding, and then the blocking is going to happen somewhere else in the topology, but not on the link between the access layer switch and core 1 if core 1 is the root. So the command that we could issue on core 1 would be in configuration mode. We could issue the command spanning tree. I'll just put span there for short. VLAN 10, which is the VLAN we want to modify. And then we could either put in the priority keyword, and we can specify a lower priority than the current root. The current priority is 8202 for VLAN 10. So for example, 4096 would definitely do that for us, because that's going to be lower. Or we could say spanning tree VLAN 10 and simply say root, which would identify what the current root's priority is, and it would do better. It'd be lower than that, and then also identify if you want it to be the primary or secondary device. And either of these options are available to us. Let's go ahead and use this one. Let's go to core 1 and issue the command spanning tree VLAN 10 priority 4096. That'll make this the new root, and as a result, this port right here 1/0 will no longer be blocking, and Bob's traffic, as it goes down towards router 1, will start using the more optimal path here because of the layer 2 forwarding that spanning tree is controlling. So let's jump over to core 1, and we'll tell core 1 that for VLAN 10, it's going to have a better priority than the current root, which will make it the root. So we'll go back to core 1, and in core 1, we'll go to configuration mode, and we'll issue the command spanning tree, VLAN 10, space, and let's take a look at the question mark. So here's where we could specify root, where it would go out and just beat it, or we can use the keyword priority. And that's our plan. Let's go ahead and use the priority keyword, and then we're going to specify a priority in increments of 4096. And if we're not sure what those values are, you can type in a bogus number like this. It'll say, hey, here's the possible values. So we'll hit the up arrow key, and let's use 4096 as the priority for this switch, core 1 for VLAN 10, and we'll press enter. Now once we've done that and do a show spanning tree for VLAN 10 and press enter, notice how gig 1/0 is still blocking? Well, check this out. That won't be the case for very long. It's going to be going through its listening and learning states here in just a moment. We'll use the up arrow key again. Now it's in learning, and in just a few moments, it'll be forwarding. So hit the up arrow key again, and survey says, oh, it's coming. And the cool thing is that if you want to do this lab a couple times or a few times, you can do this and actually see the states change just by issuing the show commands while spanning tree is doing its conversions. So let's do the up arrow key one more time, and there we go. It's now forwarding. So now in our topology, if we go to our access layer switch and hit the up arrow key for show spanning tree for VLAN 10, we can see where the blocking's happening. And currently it's happening right here on gig 0/2 in our topology. That's where the block is happening now. And if we look at that topology, that's the link from the access layer switch down to core 2. It also means that Bob's layer 2 path, as a result of us modifying spanning tree, is now taking a more optimal path through the layer 2 network as his traffic goes from his PC to the access layer switch, down the trunk to core 1, and then down to router 1 and points beyond. So in this video, we did a few things. Number one, we reviewed the idea of how spanning tree controls the layer 2 path by blocking on certain ports so there's not a layer 2 loop. Also, we identified how we would verify what that path is with the show spanning tree command for a given VLAN. And then third, we manipulated or changed spanning tree by making core 1 the root for VLAN 10 for that spanning tree, which changed the layer 2 path of Bob's traffic as he sends packets out to the internet. So I'm glad you joined me for this lab and video, and I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.